Welcome back, ladies and gentlemen. So this is a little bit of practice for your upcoming Trig test, your SOHCAHTOA. Right. So at the very top of this test, or practice test, I'm going to write down SOHCAHTOA, right, which again represents sine is opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent. And if you forget what the S, C, and T stand for, if you look on your calculator, it's right here. Sine, cosine, and tangent. Okay? So, here we go. You solve for x using knowledge of trig ratios, round interest, nearest tenth. Okay. I'm trying to find a side. So I'm going to first label or circle my angle. Across from it is opposite. Across my right angle is my hypotenuse, which makes this my adjacent over here. Now, the problem gives me an x and it gives me a 17. I've got nothing right there. So I'm trying to see which trig ratio uses O and H. So up here, O and H is, bam, sine. Alright, so sine of 43 degrees, it's always of your angle, equals O, which in this case is 17, over H, which is x. Please note where the x is. X is in the denominator. So technically what I'm doing here is multiplying both sides by x. That gives me x sine 43 degrees equals 17, because the x's cancel out. And to get x by itself, I'm going to divide by sine 43. Okay, so if I take my calculator and I go 17 divided by sine 43, 29.9, round to nearest tenth, there we go. Oh, 24.9, I can count. I think that was right. Okay, very good. Alright, so for part B, okay, much the same. I'm trying to solve for x. Circle our reference angle. Across from it is my opposite. Across from 90 is my hypotenuse. There's my adjacent. Well, there's my x. There's my number. So if I cover up the adjacent again, O and H, again we're looking at sine. Sine of 23 equals O over H, x over 16. Now, please note, first problem, x was on the bottom. Over here, x is on top. This is actually a little bit easier. You just multiply both sides by 16. So x is going to equal 16 times sine 23 degrees. Pardon me. 16 times sine 23. 6.6. No, 6.3, man. Have a sleep, guys. My apologies. Okay, look at the 5 there. My bad. Okay, good. Now, for both those problems, we are solving for side lengths. If you take a look at number 2, we are finding an angle. Okay, this is when we use second and then the trig button on the calculator. Alright, so we're trying to find angle N. How do I know it's angle N? It says it right there. So I circle angle N, go across from it, there's my opposite, across from 90 is my height, hypotenuse, and then there's my adjacent. Okay, so in this case, 21 and 19 are what's given to me, so O and A. Alright, O and A, if I look at my SOHCAHTOA up top, is going to be tangent. So, tangent of N equals O over A. Now, in order to solve for my missing angle, we have to use what's called the inverse trig functions. So tangent inverse of 21 over 19. Well, what the heck is that? Well, I take this and I hit second tangent. 21 over 19, 47.9. Make sure you put degrees there. It's very important. Okay, awesome. Alright, so, very good. Again, degrees, we're good. So over here for angle N, circle our angle. Okay, go across. That's my opposite. Hypotenuse is always across from my 90 degrees. And there's my adjacent. So take your time, label things correctly. Now on this one though, I'm only given the O and the H. There's my sine. So sine of N equals 3 over 7. To find angle N, I must do second sine, get my sine inverse, Okay, so here's my calculator. Second sine, 3/7, 25.4. And again, degrees for angles. Cool. Awesome. Okay, so then use the diagram with the right to answer the following. Reduce fractions when possible. This is the easiest problem on the entire test. Two things you know how it is when it says reduce fractions, and also it gives you all three sides. Sine is opposite over hypotenuse. So if the angle is x, you circle x. Opposite is across from it. Hypotenuse is across from 90. There's my adjacent. So O over H would be 16/20. Where am I getting those numbers from? Just looking at this picture. And now I can go 16 divided by 20. Math, enter, enter, 4/5. Okay. Cosine is adjacent over hypotenuse. So A over H, 12/20. Okay, same idea. 12 divided by 20. Math, enter, enter, 3/5. Okay, cool. Tangent is opposite over adjacent. So you're looking at 16/12. Okay. Math, enter, enter, 4/3. Cool. So, again, just make sure you guys are comfortable with labeling opposite, adjacent, hypotenuse, and you'll be in very, very good shape. Okay. On your back. Some word problems. Okay. You are flying a kite and have let out 95 meters of string. So, there you are. There's your kite. Okay. So the string is right here, 95 meters. The kite's angle of elevation with the ground, okay, is 42 degrees. If the string is stretched straight, how high is the kite above the ground? Now the height is right here, so I'm trying to find that. Okay, there's my angle. There's opposite, because it's across from it. There's hypotenuse. Which trig ratio uses O and H? I'm sorry, I still have sleep. Man, I gotta wake up. So that would be sine of 42 degrees equals x over 95 meters. Alright, so to find this one, 95 is in the bottom, multiply both sides by 95. X equals 95 sine 42 degrees. Okay, 63.6 meters. Don't forget units, 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 units. Okay, very important. Okay, a bird sits on top of a telephone pole. Okay, that's the worst bird of all time. Tweet, tweet. Okay. Okay. Kim is 40 feet from the base of the pole. Well, here's the pole. So Kim's over here. If the angle of elevation from Kim's feet to the top of the telephone pole is 23 degrees, what's the height of the pole? Okay, so much the same. Circle the angle, label opposite. Now, this is your hypotenuse. Down here would be your adjacent. Okay, so which trig ratio uses O and A? TOA. So it's tangent of 23 degrees equals O over my A is 40. So 40 is on the bottom, multiply both sides. It's basically the same thing, but what you guys want to worry about is which ratio to pick. So 40 times tan 23, 16.97. Careful here because this rounds up, so if I'm going to round the nearest tenth, that bumps it up, and this would just be 17. And we're talking about feet here. Very good. All right. So those two we're talking about the heights and how high and how long, like different lengths. The last two we're going to be talking about angles. Okay. When we're talking about angles, you need to make sure you're using second. So Rachel's kite has a string 40 feet long. So here's Rachel. Here's the kite. 40 feet long. And it's flying 27 feet above the ground. What's the angle of elevation? Well, ladies and gentlemen, the angle of elevation is always kind of like where the ground is, right here. Call that x. So there's my angle. Across from its opposite. There's my hypotenuse. Which trig ratio uses O and H? Sine. So sine of x equals O over H. Trying to find the angle. Sine inverse 27 over 40. So this is second sine. 42.5 degrees. And again, it's an angle, so don't forget units. Degrees. Okay. Alright. Last one then. An airplane is flying high. Okay. Looks more like a shark. Okay. Height 2 miles above the ground. The distance along the ground from the airplane to the airport, okay, is 5 miles, so on the ground. So that's 5 miles right there. What's the angle of elevation of from the airport to the airplane? So here's my x. So here's opposite. Here's adjacent. That would be tangent. So tangent of x equals O over A, 2 over 5. So tangent inverse of 2 over 5. Okay, so I'm just going to hit second tan on here. 21.8. And that would be 21.8 degrees. Okay, so good stuff. Oops, pardon me. That's all we really know. Just know your trig ratios. You guys will be in good shape. Okay, so as always, keep the good work and good luck. We're all counting on you.